I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranhagon!
All right. All right, let's get back. Okay, so what's a vector? It's a quantity that has a magnitude, which is like a size, and a direction. That's the important thing. Magnitude and direction. All right, so there's two kinds of quantities in physics. Scalar and vector. Scalar is just magnitude. So, temperature, right? Temperature doesn't have a direction, A vector has magnitude and direction. Like a force, right? A force, has a magnitude and a direction. Okay? So we're going to use a lot of vectors in physics, okay? Lots of vectors. So what we need to learn is how to add and subtract vectors. So here you go. All right, so this is how you signify a vector. So A, and then it's a vector because you put a little arrow on top. Now actually, in the real world, most people like me are way too lazy to do that. And so you just go like this. All right, just put a line over it. Whenever you see a line over it, you know it's a vector. And make sure you do it, or else you're going to get totally confused. Okay, so this is the tail, and this is the head. So think of an arrowhead, right? And this is the tail. So that's how, all right? So obviously that's the direction, and the length of the vector gives you the magnitude, how large it is, okay? All right, so what we're going to learn is the head to tail method of adding vectors. We're going to learn a different method later on. All right, so let's go. So if you've flown from the U.S. mainland to Hawaii and then back again, now it's the same distance, but you notice it takes a different time. Why is that? Because of the wind, right? One way the wind is with you most of the time, and the other way the wind is against you most of the time. So when the wind is with the airplane, it goes faster. When it's against, it's slower. And you probably already know that, especially if you jog or ride a bike, like on a Malakahana bike path that goes to Kahuku. Usually, when you're going from Laie to Kahuku, the wind is with you, so it's easy. But when you come back from Kahuku to Laie, the wind is right in your face, so it's hard. All right, so that's really what we're talking about. Okay, so here's an airplane. So again, that's the direction. And the length is the magnitude. Here's a wind, same direction. So what's going to be so you want to add, right? So you want to add. So you want to add two vectors. So this is how you do it. It doesn't matter the order, all right? So here's the wind. Could have been the airplane, doesn't matter. So here's the wind, and it's head to tail. It's the head of the wind vector and the tail of the airplane vector. So that's what you do. You just think of it as like attaching them. Head to tail. So wind, head, tail, airplane, same direction, right? And so when you add them, the sum is just this whole thing, right? It's kind of like from the beginning of the tail of that to the head of that, all right? It's the whole thing. So as you know, if the wind is with you, you go faster than otherwise. All right, how about this? So the airplane's going this way, but then you have this incredible crosswind like that. What's it going to do to the airplane? So let's just do it. All right, so again, doesn't matter, the order doesn't matter. So here, let's do airplane first. This doesn't matter. Airplane first, head to tail, right? Head of the airplane, tail of the wind, right? And then it's from the beginning or the tail of the airplane to the head of the wind, right? I like to just think of it as the beginning to the end. So this vector here represents what would happen. Okay, that's the sum, all right? Okay, now this is kind of ridiculous, but let's just do it anyway. So let's say you have a runner going this way, and there's this crazy wind going that way. So opposite direction, same magnitude, right? So here's the runner. You connect them head to tail, right? So what's the sum? Well, it's from here to here, which is nothing, right? So the sum is 0, okay? All right? Okay. Let's do this. So this is kind of like coming back on the Malakana bike path from Kahuku to Laie on a normal day. So, you know, you're going pretty fast, but then you have this headwind right in your face. So you get at it. So let's do it. So here's the runner. Then you attach them head to tail. There's the wind. And what's the sum? You go from the beginning to the end, right? Beginning to end. Or the tail of the runner to the head of the wind, however you want to look at it. And so that's the answer, okay? That's the sum. Okay, now, we don't really do a lot of adding of vectors, to tell you the truth. What we do a lot is subtracting, and you'll see why. So we have to learn how to subtract a vector. Well, in order to subtract a vector, you have to know how to add. That's why we did it first. So here's just simple math, right? So vector A minus vector B is the same thing as vector A plus a negative vector B. That kind of makes sense, right? Well, what's a negative vector B? I'll hold it. Okay, so let's say that this is vector B. Well, what's negative? What do you mean negative? Well, remember, magnitude and direction. So if you have a negative, it just means it's opposite direction. So if that's B, that's negative B, okay? It's supposed to be the same magnitude. I don't know if it is enough, but close enough. In opposite direction. That's what we mean by negative B. Okay, so let's do a couple. All right. So I'll do one, then I'll have you do some. So we want A minus B. Again, just write it down. That's the same thing as A plus a negative B. Okay, well, A is sort of kind of like that. I'm not going to be super picky. Right, that's A. Now, B is like that, but we want negative B. So negative B is like that. And we want to attach them head to tail. So I don't know, something like that, minus B. And then you go from the beginning point to the end point. So it's like that. So that's A minus B. Okay? Yeah, okay, I'm just going through the steps, right? A minus B is the same thing as A plus a negative B. If that's B, that's minus B. And then you connect them, and you go from the beginning point to the ending point, and you get that. Yay! So that looks kind of sort of like mine, right? All right, that's all it is. Okay, now, I want you to do this, please. So, because you've got to get practice. I mean, we're going to be doing this all semester. You have to know how to do this. This is just basic. This is like learning how to crawl. All right, so everybody pause your video and find the sum, A plus B. So that's an easy one. It's a plus. All right, you're back, I assume. So we have A, something like that. Then we connect B, head to tail, right? Head to tail. So B is something like, I don't know, something like that. Again, I'm not too picky because I don't have graph paper. So there's A, B, head to tail. Then you go from the beginning point to the ending point. So that's A plus B. All right, so, okay? All right? All right, now do that. Okay, now wait a second. I had you do this, right? And we explained this. Now do that. So pause your video and do that. you should have your answer already. All right? I mean, what's the difference between this and this? Nothing. Right? Because remember, a vector has magnitude and direction. Position is irrelevant. I don't care if it's I don't care if it's there or there, right? It has the same magnitude, has the same direction, so it's the same answer. All right? So I did that on purpose. Okay, let's see. Okay, pause your video and do that one, please. All right, let's do it. So b minus a is the same thing as b plus a negative a. So b is kind of like that. That's b. Minus a is that way. Minus a is that way. And you go from the beginning, or the tail, to the head. Oh, close enough. So that's b minus a. All right? Okay, now, try to, if you have graph paper, it would be best, but if you don't, it's okay. This vector has the same magnitude as that vector. Okay, pretend that here's a horizontal line. This angle is the same as that angle. So try to do this one really, really carefully. I mean, I haven't been super careful here, I admit. Try to be super careful. So pause your video and figure this out. This is incredibly important. We're going to see this a million times, maybe 1,000. All right, we're back. So again, b minus a equals b plus a negative a. Okay, I'm going to try to be careful, but it's kind of hard on a whiteboard, you know? All right, so we want b. So here's b. So that's b. And then we want negative a. So negative a points like this. That's negative a. And then we go from the beginning to the end. And there you go. So that is, this vector right here is b minus a. We're going to see that so many times. Anyway, just trust me, all right? That's important. All right, that's a good place to quit.